Welcome to EDU World Space.
So we're given that a carbon resistor uh, is going to be used as a thermometer, and on a particular day, there is a temperature at 4 degrees Celsius, which has a corresponding resistance of 217.3 ohms. And I've just labeled these with W because the problem says on a winter day, so just put W for winter. And we're told that the reference temperature is 4 degrees Celsius, and they want to know on a different day when there's a when the resistor has a resistance of 215.8 ohms, what is the temperature on that day? So we can solve this problem if we have an equation that relates resistance to temperature, which uh, we actually have one. So equation 25.12 gives you the resistance as a function of temperature is equal to some reference resistance, 1 plus alpha, which is some coefficient, and then the temperature. And alpha can be found in table 25.2. So, and this alpha will be alpha corresponding to carbon. And it has units of inverse Celsius. So our goal here is to find R of T. The resistance is a function of temperature, but we don't know this reference resistance. So we know alpha, which we can find from the table, and we know these two temperatures. So using the information that we're given, let's find R of T. Or rather, let's find R naught, because we have an R of T. Okay, so at a particular temperature of 4 degrees Celsius, we have RW, right? So that's equal to R naught, 1 plus alpha TW minus T naught. But the reference temperature and TW are the same, as we can see here, right? So this difference is 0. So that tells us that the reference resistance is equal to RW, which is already given to us as 217.3 ohms. So now we have all the pieces that's necessary to find the resistance R to find the temperature TS that corresponds to RS. Let's do that on the next page. So I'll write that RS is equal to R0, 1 plus alpha TS minus T0. Okay, but we're interested in finding this temperature Ts. So we can rearrange this equation in order to isolate the temperature. So we can divide by R0, which gives us 1 plus alpha Ts minus T naught. And then subtract 1 from both sides. And this side I could put over a common denominator. and then divide both sides by alpha. And then finally, to isolate TS, we just move T naught to the other side, so we have RS minus RS minus RO over alpha RO plus T naught is equal to TS. So we have everything here on the left-hand side. So if we were to plug in all the numbers that we have, then we'll have 215.8 ohms minus 217.3 ohms divided by alpha, which is minus 5 times 10 to the minus 4 over degrees Celsius. So it's inverse Celsius times R0, which is 217.3 ohms. The numerator is negative and the denominator is negative, so we get a positive number. So we don't get a negative temperature. So we have TS is equal to 17.8 degrees Celsius.